It is my great pleasure to introduce our CEO to speak to you this afternoon. I'd also like to point out for the first time here at ARC, for many of you who probably don't know her but know her name, we have Christine Byrne from our PR organisation stood at the back there. So if you haven't met her before, that's who she is. And she has our annual report for those of you who don't know who we are, and our Year in Infrastructure book as well. But without further ado, I'll hand over to Greg.
Many thanks, Anne-Marie, and thanks to each of you for your interest in asset performance modeling. So ARC's mandate for us this year, a new age of innovation. Here's the marching orders from ARC having to do with convergence. I think there's even more convergence than that. And if so, could we hold ourselves to the standard if there's a new age of innovation, of attracting and appealing to digital natives, our next generation? See what you think. So Bentley Systems is new to some of you. To how many is Bentley Systems new? So we have some annual reports there from 2014. We don't have a 2015 annual report yet. We filed to go public as a company after 30 years. The annual report tells our 30-year history, so I'm not going to do it now. We're still waiting for a congenial public market, but we're philosophical about that. And it gets further away by the day, but that's okay. We've been at it for 30 years. Our endeavor to advance BIM, you may have heard of BIM. Our way of defining it is at the same time we seek to improve project delivery and to have better asset performance. And in the case of project delivery, better is achieved through greater breadth of information mobility, and for better asset performance, the BIM, better depth of information modeling. We endeavor to make advancements on both axes at the same time. So you can say we start with CapEx, but focus at the same time on OpEx, because it's all about TOT-EX. And wouldn't we like the TOT to be X as we improve value and asset performance? That's something that we feel uniquely able to work on at Bentley Systems by virtue. Over our 30 years, we started with MicroStation and applications for information modeling, then our collaboration environment project-wise for integrated projects to yield intelligent infrastructure supported by our asset-wise services. And the opportunity is for digital engineering models created at this stage to converge to pay off for the owners in intelligent infrastructure. These are our Bentley applications to support infrastructure assets, as we term them, everything that's built to improve the world. The blue ones are applications that are new over the course of the past year. So our applications create the digital engineering models for our infrastructure in the world. And ARC, we respect very much the market rankings. We're number 2 overall for engineering design tools for plant and infrastructure, and number 1 in many categories of interest to you and your readers, but also in terms of asset reliability software, number 2 overall and number 1 in many relevant markets as we work on both those axes. And here today you have, in terms of asset performance management, something we released in November describing the latest release of our asset performance management software to better serve risk-based inspection and work better with SAP and so forth. We annually award Be Inspired Awards for our users' projects. In 2014, Innovation and Asset Performance, a finalist was the Malaysian power company. I visited there last spring, and we got an award for their improved asset performance from the CEO of Tenaga. We publish each year in our infrastructure yearbook, and you have that to take away today, hot off the press, but you've perhaps been looking at the digital copies, the projects nominated and awarded each year at our Year in Infrastructure conference. And how many join us in London for that conference? You are all invited, and we'll be there again this November. When I was here a year ago, I announced our acquisition of Amulet in operational analytics, serving many sectors of interest. And since then, Gartner, who keeps track for, as they say, asset performance management, have reckoned us as capable as any, and including the next General Electric. We know how hard and effectively they work on the industrial Internet of Things, so we accept the challenge to go further even. And one of the users of Amulet has put it all together for operational analytics. It started actually in Adelaide with this desalination plant that they built during their long drought. Its design won our Be Inspired Award in 2009. So they had great digital engineering models when 2 years ago they were ready to operate the plant. And so they pulled together the following accomplishment for converging IT, OT, and these digital engineering models for ET. They won the Global Water Performance Initiative of the year 2014 and were our winner last year. So I'm going to let them tell that story a bit.
In South Australia, SA Water has introduced predictive and real-time operational analytics through Bentley's Amulet software, improving customer service while reducing operating costs.
I think the tools we've developed here are an example of the sorts of things that will be very common in the future in industry, especially industry with large asset bases where you've got complex things to operate. It allows you to take a variety of inputs and make the best possible decision. In our case, we've got some sophisticated optimizers we use that Amulet sits around, and it makes a big difference to the way we organize our network and how effectively we can operate.
The scope of the inputs he's talking about, the diverse inputs, are for the first time with Amulet, we can bring in environmental inputs, the weather, which is key to their, to South Australia Water's demand, and their network operations model reflects their engineering technology, the digital engineering models by which they can treat their plant and reservoirs in effect as a huge pump storage opportunity with which to optimize not only their operations but their electricity consumption and have visibility across their network and plants, as you see here, to pull together, and this is their presentation. The last aspect of it is to tie it in with the actual forward market for buying electricity, which is priced per time of day and is very volatile in Australia, and that closes the loop on the savings in TOT-EX that they achieve through this convergence. I've gone very quickly through that story because it's been reported by Gartner, and you can see that lessons for integrating IT and OT with ET from their successful operational intelligence system. So asset performance monitoring, there's a lot of headway we make in the industrial Internet of Things by connecting our real-time inputs with librarians and databases and transactions of history. But, and when we do that, we can have big data computing work hard enough to discern patterns and respond to them. But what if we could also consider the operating baseline for our infrastructure assets, the digital engineering models that were the work of the engineers in the first place? And they take these forms, schematics and 3D models, catalogs and functional components, analyses, network models. They're, you might say, inscrutable to start with, but we've created those digital engineering models, or we understand the software that has done so, and we can make those digital engineering models, if you like, the digital DNA for each of these assets. So you might say we advance today with individual health. We can have our own monitoring of our health so that when we would go to the doctor wouldn't just compare our blood pressure to everybody else's blood pressure, but to our own history of our blood pressure. That's where we are with the industrial Internet of Things today, perhaps. But suppose that the doctor could have access to our DNA. We know that lies ahead in the future. The genome is not quite so simple. For our infrastructure assets, we do have the DNA by which they were created. It's the engineer's work in our digital engineering tools. And those can form the intelligent baseline. If we can put it together in the same frame of reference for what we're observing and operating, we can go from asset performance monitoring to asset performance modeling. And I think that really is the key to come to this industrial Internet of Things. And we have intelligent hardware of every sort for computing, for mobility, for positioning, for imaging. Especially now we have UAVs and drones. It's the digital engineering models that can connect all that together intelligently for the actions it would take. For instance, I'm going to use the example of a substation because it's part of all industrial assets, and we'd like to be able to go right into the asset performance history and failure modes as here, and to be able, for instance, if we're looking at our substations over a territory, to monitor where our alarms and events may occur and go right in through geo-coordination to the positioning within the infrastructure asset of what's causing the alarm and refer to their failure modes and the actual degradation we might observe in the field. If we could tie that all together, we make considerable progress. But is that for everyone? And how would we accomplish there? And can we get there right now? And my premise is we have a great head start all of a sudden. Because today we are converging OT and IT. And you might say, where are the digital engineering models? How do we complete that progress from monitoring to modeling? So that was the situation for Exelon. And we have a case study how they put together their asset performance management approach to have health indexes for each of their assets in their T&D network. The problem was, when that became out of date, they said, how do we continuously update? Is there a way that we could always be up to date? And their subsidiary, ComEd, in fact, was the first during the past year to be approved to use drones, UAVs, to inspect their T&D assets. So I'd like to tell you about closing the loop here now, how something we call continuous surveying can create the frame of reference to bring the engineering models together with the operational models. So this is Acute 3D software, which has been used for 3D city mapping from aerial photography to produce what is not a point cloud, but is an actual 3D model, a mesh, from which you could, as in this case, look at the solar gain in a city. But when we apply it industrially, we're using UAVs to take ordinary digital photographs or video, and from that, and those can be ordinary photographs with any of these devices, which our users tell us work better than they could possibly have imagined, even just from smartphones, to capture the context in a tractable 3D reality mesh that can provide this digital frame of reference, because the digital engineering models are created by digital engineering tools in a digital engineering environment that is 3D. We actually operate our infrastructure in 3D. To bring the two together is now possible, not once and not occasionally like traditional surveying, but continuously each time we extract digital photographs, for instance, from the UAVs that will be part of every plant maintenance fleet very shortly. And the key to it is what we call reality modeling software. So this is a substation in France. Just a few months ago, as you see, 286 images were taken from a drone, and then 180 from the ground using even a cell phone. Might have been a little better camera, but doesn't have to be a great camera. And that created, this is a 3D mesh model. They supplemented it with some additional close-range photography, for instance, to pick up those nameplates. And you haven't been watching the flight of the drone. You've been navigating in the environment of the digital engineering models, because this now is our microstation environment, the one in which engineers work with their design applications. And here, for instance, we can go about geo-coordinating positionally, for instance, from the nameplate. Now you'll see this is an actual mesh 3D model captured from the drone and ground photography, and we can attach or geo-coordinate, for instance, the maintenance manuals for that equipment. And I'm showing here now something that came to me just a couple days ago in our applied research group in Canada. This was an internal presentation. They're working to geo-coordinate the schematics, the P&IDs, where we know we always have up-to-date and correct P&IDs, but they're schematics, they're digital engineering models. If you put it together with the 3D model, and here my colleagues created a mock-up of a plant in 3D to bring together the reality mesh from cameras with the schematic, with the 3D model, and are showing it in their offices with augmentation where you can walk through it immersively in virtual reality. That's how we do things to work it out so that we can be introducing these new age innovations soon at industrial scale. And this, for instance, you can be asked to find, you were looking for the valve on the P&ID that would turn something off for inspection. It can show you the way. So geo-coordination, how everything is put together positionally in the same 3D frame of reference captured from digital photography of the plant. So geo-coordination, and then next we'd like to relate that to, for instance, the failure modes of that equipment, which can be brought here and indexed to this 3D operating model of the plant. And our software will put all of that together. And then our alarms and filters can be applied. These are examples from Network Grid in the UK of, for instance, for that transformer in a substation, what alarms and filters there can be, and configured who's to be notified, for what purpose, when, but have this now part of this converged OT and IT and ET environment. And then you may use the drone in this case. This is a thermographic, not a photographic record. These images of the thermography as well could be resolved into a 3D model for early alarm conditions in that substation. And now I'd like to show what can be done with video as a continuous survey. So this is a bridge that's instrumented, as you'll see, but it can be observed by video where the motion is magnified. These tricks are available in video now. It's conventionally censored, so OT is going strong here. But it turns out, this again is just our research, if you set up a video observation to produce this data, then in conjunction with the structural model, the original engineers work on that bridge, this is an actual bridge, then compared to accelerometers, even if you censor the heck out of the bridge, they're a limited number, you can monitor as many points as you like in the video, and you end up solving for the modes of deflection and ultimately risk in the bridge, and the video has actually done a better job than the conventional censoring of that bridge in understanding its structural characteristics, which could lead to alarms and filters. So deep learning can be applied to video as well. In this case, a deep learning program watched an operator go through the video of driving a roadway to learn when the operator clicked on a road sign, and then inventorying the road signs after just a couple hours of training, this program has done this very well. Imagine how much better it could from a 3D reality mesh model of your assets to help classify and link this converged environment together. So then in our substation, we're now back to engineering. If we're modernizing that substation, we'll refer to our catalog of transformers, and this is the way in which work is done now in 3D and schematic mode together in our applications. But here we are in MicroStation, starting with the context of the actual reality mesh captured in that plant and adding in our new engineering, including new transformers, I guess, that is right in the context. So the acquired continuous surveyed model from the drone is the point of departure for the engineering of an upgrade to that substation. And why don't we harden it while we're at it? This is outside Paris with new walls and lights. So then there's construction to follow. And we can fly our drone every couple days or a week. And here you see a way of presenting, and we could be doing this interactively, the condition in construction being differenced from one flight to the next. Imagine now that this could be done also during operations to monitor corrosion and so forth, where you're always aligned thanks to the reality mesh process. The benefit of surveying can now be continuous. So the conclusion, of course, is in the field where devices look like this now and are connected, and our latest software, everything is called the Connect Edition because we're the largest partner of Microsoft in using their Azure cloud to tie everything together, because this is where the result of operational insights pays off when you can navigate through that 3D model. It's the same 3D model, the same frame of reference, 3D, by which we work and we plan and we engineer. These are the devices of today. When you create a markup in the field, it's going to go back to the engineers, the maintenance engineers, the operational engineers, the design engineers, if need be, and be synchronized. And so that same app from Bentley Systems ships with the Microsoft Surface Hub, which is this touch device you see here, and this would be synchronized in the office with what's being observed and corrected for asset performance modeling to pay off in the field. So our winner in advancing information mobility for operations this year was a project in Western Power, the largest transmission and distribution outfit in the UK, with 3,500 iPads in the field. Each one of them has the entire network model for the largest portion of the UK, and only the changes are transmitted through what we call delta changes in iModels to connect and close that loop in the convergence between ET and IT and OT. And this then gets back to our digital natives with the hard part has been creating that frame of reference, the same 3D frame of reference for IT and OT and ET. And who knows what the mobile devices will look like for our digital engineering models, for asset performance modeling, for and attracting our digital natives going forward. Thank you for your interest, and we have time for some questions.